Okay, in this video I'll be going through general properties of waves, success criteria E, which is to compare transverse and longitudinal waves and give suitable examples of each. Now there are two types of wave motion. One is transverse, the other one is longitudinal. Okay, so what are transverse waves? They are waves that travel perpendicular to the direction of the medium's particle vibration. So this wave actually has a direction. Okay, and the direction of the movement of the wave, it is perpendicular to the direction of the medium's particle vibration. So there are actually two directions. Okay, one direction example is the wave direction. Okay, but in order to create a transverse wave, the particles must vibrate in the vibration direction. Okay, so the blue color arrow shows the particles vibration direction or their movement direction, and it is actually perpendicular to the wave direction. So therefore this is the definition that you need to memorize. Transverse waves are waves that travel perpendicular to the direction of the medium's particle vibration. Okay, as you can see from the diagram here, the hand is moving up and down, right? And it causes the spring or the particles in the spring to move up and down as well. However, the wave direction is away from the person that is oscillating the spring. Is in fact perpendicular. Now, what are some examples of transverse wave? All this can be used: water waves, light waves, radio, microwaves. Okay, so try to stick to this. Seismic S wave, it is actually from earthquake. Okay, it is a transverse wave. Okay, the other type of wave is longitudinal waves. Okay, as you have already memorized the transverse wave and you have used the keyword of perpendicular, you can use the same definition. However, in this case, longitudinal waves are waves that travel parallel to the direction of the medium's particle vibration, which means to say, if the wave is moving in this direction, okay, the particle is actually vibrating in the same direction, which means it is parallel to the direction of the wave. So again, there are two directions and both are parallel to one another. So you can use the spring again to illustrate. Okay, so basically the hand is moving the particles or moving the spring left to right. Okay, left to right, and the wave is also moving in the same direction. Okay, now state what is meant by wave motion and hence describe how water in the ripple tank provides an example of transverse wave motion. Okay, so this is the answer. First of all, you define what is wave motion. Okay, so wave motion is defined as a disturbance, remember that was the keyword, that moves from place to place in a certain medium, carrying energy with it, and without the physical transfer of any material between the places. Okay, so the next mark is describe how water in the ripple tank provides an example of transverse wave. So the water waves is a transverse wave, right? It consists of oscillation occurring perpendicular to the direction of energy transfer. Okay, now we go to question E2. Which of the following shows correct examples of transverse and longitudinal waves? Just now I mentioned a lot of examples for transverse wave. So if I see it didn't mention sound, so sound is actually not a transverse wave. In fact, sound is a longitudinal wave, and it is one of the I think it's the only one example in O level, okay, that you can quote. So longitudinal wave, it is sound wave, and then therefore it will be easy. Gamma rays is also a transverse wave. It will be covered later on in the EM spectrum. So for this, answer is D.